Okay, in section 9.4, we're studying operations with functions. So in your chart there, there's 4 operations: addition, subtraction, multiplication, division. We notate this: f plus g of x is f of x plus g of x for addition. For subtraction, you have f minus g of x, which is f of x minus g of x. Multiplication, f times g of x is f of x times g of x. And f divided by g of x is f of x divided by g of x, where g of x cannot be 0. So when you're doing these, you need to make sure you note any domain restrictions that may arise, just like you did when we studied rational expressions. So here, let's just jump into an example. Number 1, given f of x is 3x squared plus 5x plus 2, and g of x is 4x plus 5, find the function f plus g of x. So we're going to rewrite this f plus g of x as f of x plus g of x. We know what f of x is, so we're just going to plug in f of x. It's 3x squared plus 5x plus 2. Plus, we know what g of x is. It's 4x plus 5. Nothing to distribute in the first set, so we're just going to drop the parentheses. Always make sure parentheses when you're plugging in your function. So this will be 3x squared plus 5x plus 2 plus nothing to distribute in the second set since there's just a 1 out front. So this will be 4x plus 5. Simplifying this is just combining like terms. So you get 3x squared plus 4x, and 5x is 9x, and 2 and 5 is 7. So, and then we'll notate this as f of x plus g of x equals 3x squared plus 9x plus 7. Number 2, given that f of x is 3x squared plus 5x plus 2 and g of x is 4x plus 5, find the function f minus g of x. So f minus g of x is f of x minus g of x. Again, use parentheses where you're substituting your f of x. So this would be parentheses 3x squared plus 5x plus 2, close your parentheses, minus g of x, which is 4x plus 5, inside parentheses. First set of parentheses, nothing to distribute, so we can just drop the parentheses. So this is 3x squared plus 5x plus 2. Next set, you need to distribute the negative 1. Negative 1 times 4x is negative 4x. Negative 1 times 5 is negative 5. Simplifying this, you have 3x squared. 5x minus 4x is x. 2x minus 5 is negative 3. So we would say f of x minus g of x is equal to 3x squared plus x minus 3. So this is adding two functions together is nothing more than combining like terms. Example 3, given that f of x is x squared minus 4 and g of x is x plus 2, find the function f times g of x. So again, we'll rewrite this. F times g of x is f of x times g of x. I'm going to use FOIL, although you could also use the box method. So x squared minus 4 times x plus 2. X squared times x is x cubed. X squared times 2 is 2x squared. Negative 4 times x is negative 4x. And negative 4 times negative 2, negative 4 times 2 is negative 8. So nothing, no like terms to combine, so we'll leave our answer like that. So f of x times g of x is x cubed plus 2x squared minus 4x minus 8. Example 4, given that f of x is x squared minus 4 and g of x is x plus 2, find the function f divided by g of x. So we'll rewrite f divided by g of x as f of x divided by g of x, and we have the restriction that g of x cannot be 0. So we'll plug in our f of x is x squared minus 4 divided by x plus 2. And then now you're back to, you need to use your factoring techniques to factor the numerator as x plus 2, x minus 2 divided by x plus 2. So the x plus 2's would cancel off, and you would get f of x divided by g of x equals x minus 2. But then you need to go back and state your domain restriction. So you have a domain restriction. So g of x cannot equal 0. In this case, g of x was x plus 2. So x plus 2 can't equal 0. Solving that for x, you say x cannot equal negative 2. So f of x divided by g of x equals x minus 2. Your domain restriction tells you that you cannot have x equal to negative 2. So all of this first 4 examples was really reviewed. The first 2 really from Algebra 1, and even 3 is from Algebra 1. But we've seen all of these examples before in some way, shape, or form. The newest one is this idea of the composition of functions. The composition of functions is notated as such, and it's read as f of g of x. We're going to use this second notation the most often. So this is just that the domain of f of g of x is all the values of x in the domain of g, such that g of x is in the domain of f. So let's look at that with an example. And I like, again, to think of this, before we get to an example, I like to think of this as a function machine. So remember, with BASIC, you had your input. So whatever was going into your function, your input, and you had your function, and then you had your output. So the difference here is that when you're inside your machine, you have 2 different functions. So whatever function's on the inside is going to get done first, and then you do the function on the outside. Just like you think of order of operations, whatever's in the parentheses on the inside, you do those first. So your steps for evaluating composite functions. Evaluate g of x first, and then evaluate f of x. So evaluate the inner function first, and then evaluate the outer function. So let's look at an example. So given that f of x is 3x plus 1 and g of x is x squared, find the following values, and then they want the function machine to be drawn for each. So for example A, f of g of 2. First you find g of 2 since that's on the inside. So g of 2, well, I know g of x is x squared, so g of 2 is going to be 2 squared, which is 4. And then I'm going to write f of 4, because that's a g of 2. F of 4 equals 3 times 4 plus 1, just using the function for f of x. So 3 times 4 is 12, plus 1 is 13. So your function machine for this one, here is your g of x function. So g of x equals x squared. And the value that we input there is 2. What came out when we put in 2 was 4. And that's going to be the input of our f of x, which is 3x plus 1. That output will be the answer to this composition of functions. So when we put in 4 for x, we got 13. So we say f of g of 2 equals 13. Part B, I'm not going to draw the function machine for that one. You start with f of 2 first this time. So f of 2 equals 3 times 2 plus 1. 3 times 2 is 6. Plus 1 is 7. So I'm going to take 7, and now I'm going to do g of 7. G of 7 is 7 squared, which is 49. So you would write g of f of 2 is 49. Next example. H of x equals 7x plus 5, and k of x equals x plus 5. Find h of k of 2. So you find the inner first, so k of 2 you plug 2 in for x for your k value. So 2 plus 5 is 7. Then you plug in, substitute that. So this would be h of 7. H of 7 is 7 times 7 plus 5, which is 49 plus 5, which is 54. So we would write h of k of 2 is 54. Example 3, they give you a graph and you need to plug in, you need to find the value of g of x at g of 2. So given that f of x is 5x plus 2. So we're going to use this graph to find the value of g of x at x equals 2. So this always gives you like an x value. So x equals 2. So when x is 2, y is 4. So we would say g of 2 in this case is 4. So f of g of 2, well, I know g of 2 is 4. So I would say f of 4 is 5 times 4 plus 2. 5 times 4 is 20, plus 2 is 22. So I would say f of g of 2 is 4. So you can always, is 22. So you can always use the graph if they give you it. Last example, example 4. Given that f of x equals 5x plus 2 and g of x equals 2 over x minus 1, write the composition of functions for f of g of x. So start with g of x. Notice I'm not substituting anything in for x this time. I'm just leaving it as x, and that's fine. You can do that. So f of g of x, well, that's just going to be f of 2 over x minus 1, which is going to be 5 times 2 over x minus 1. Just substituting that in for my x. Multiplying these fractions together, 5 times 2 is 10 over x minus 1 plus 2. And this would be f of g of x equals 10 over x minus 1 plus 2. If you want to get common denominators, you could do that, or you could just leave your answer like this. This will be fine. So if you have questions, please bring them with you. Make sure that you get them answered in class.